So for that purpose, we have to measure the area of each connected sheets. This is the area of the first sheet A1. The connected second area is A2. Third area A3. A1, A2, A3, A4, etc. be the areas of the each components, each sheets. Each area will have their own center of mass. For example, for a rectangular sheet, the center of mass will be the center of the rectangle, right? So each area, each sheets will have their own center of mass. X1, Y1 is the position of the center of mass of the first sheet. X2, Y2 is the center of mass of the second one. X3, Y3 is the center of mass of the third one, etc., etc. My objective is I want to find the center of mass of the connected sheets. Denoted by position is capital letter X, capital letter Y. Capital letter X is given by, it's very easy to memorize, A1 X1 plus A2 X2 plus A3 X3 Y, A1 plus A2 plus A3. Just memorize it, very easy to memorize, right? And Y coordinate of the center of mass is A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. I have already discussed in the last class. Let me discuss problems. You have already written, right? Raj, Aaron, Devasri. Do you remember Ashlyn? You have already written this. Can I go to the next page? Is that okay? Can I go to next page? Hello?
Yes, sir.
Devasri.
Yes, sir.
Okay. You have written this formula. Is my voice breaking? Is it audible? Raj, Devasri, Aaron, Ashlyn.
Yes, sir.
Okay. Let me discuss one question from textbook. All the numerical question you should practice. Numericals is very, very important. Okay. So this is taken from textbook example 6.3. Find the center of mass of the uniform L-shaped lamina. Lamina means sheet, understood? Sheet having some thickness, fixed thickness. For example, a metallic sheet, something like that. L-shaped metallic sheet, thing like that. With the dimensions are shown. The entire dimensions is given. We need not worry about that. All the dimensions will be given to us. The mass of the lamina is 3 kg. It is actually not required. Okay. The mass is actually not required. We have to find the center of mass. Think about a metallic L-shaped sheet. I have to keep my finger somewhere here. Then it will be in equilibrium, right? Somewhere here. But I don't know the coordinates of the center of mass. That I want to find out. The coordinates of the center of mass of this L-shaped sheet we have to find out. Have you understood the question? Devasri, Raj, Ashlyn, Aaron, everyone understood the question?
Yes, sir.
Yes, sir.
Okay. So the method is, I will tell you, the method is you have to split the sheets as you wish. Which in different ways you can split the L-shaped sheet. The one of the separation will be like this. Splitting will be like this. Let me split like this. Let me draw a dot line vertically. In that case, I will get 2 rectangles or square, whatever. I have 2 rectangles. This is rectangle number 1 and this is rectangle 2. Can I say that this L-shaped sheet is obtained by connecting? The L-shaped sheet is obtained by connecting this rectangle and this square. Understood? Yes. The L-shaped sheet is formed by connecting this rectangle and this square. We get L-shaped sheet. So this is the right way. Okay, this is the best way. So you have to split as you wish. Okay. So I have got 2 areas. One is this area, rectangle, and another one is this one. Okay. I don't want to shade it. So the first one will have a area, say A1. The second one will have some area A2. Each areas are required because in our formula, the formula requires the areas. The area of the each connected sheets we need. So let me find out area first. After that I will discuss about x1, y1, etc. So first I want to find the area of the two sheets. Till this step you are okay? Till this step you are okay? Understood? Please respond.
Yes, sir.
Okay. So let me write all the solution here. How will you find area of a rectangle? Please tell me. How will you find area of a rectangle?
Sir, length into breadth.
Length into breadth. What is the or breadth into length? Whatever. Okay. What is the breadth or length of the first one? Length means this one, longer side, right? Anyway, Ashlyn, you please tell me what is the length of this one. This is the length of the first rectangle, right? What is the length? Tell me.
Sir, can you repeat?
Question is, what is the length of the first rectangle? This is the first rectangle. Understood? I want the length of the rectangle. This one is the length. Looking at the diagram, can you suggest the length of the rectangle?
Sir, is it
Yes, 2. Because it is 0, 0. 0, comma 2 on y-axis. The distance is clearly 2. Devasri, Raj, Aaron, all of you clear? The length of the first rectangle 2, you agree with me?
Yes, sir.
Yes, sir.
Okay, I don't want to write the dimension there. It is clear from the diagram, right? Then tell me breadth of the rectangle. I will ask Raj, you please tell me what is the breadth. Breadth will be this one, right? This is the breadth of the first rectangle.
1.
1, yes, very good. It is 1. It's clear. For example, if you look at the diagram, this is 1 comma 2. 1 comma 2, understood. 1 comma 2 means this one should be 1, right? This footer. Sorry. That E coordinate of E is 1 comma 2 means that this position should be 1. The footer, understood. This should be 1. Then only above 1 you will get 1, 1. Understood. So the x coordinate of E, I mean footer, should be 1. So okay, that one is breadth or this one is also breadth. That both are same thing, right? Let me say this one, then you will not have any confusion. This is 1, right? 1. 1, 1. Below 1 comma 1, the footer should be 1. So it's clear, breadth is 1. Let me write there so you will never forget it. This is what? 2. Okay. Length into breadth, 2 into 1, 2. Area of the first rectangle is 2. All of you clear? Please respond. Devasri, Ashlyn, Raj, Aaron.
Yes, sir.
Okay.
Yes, sir.
Now I want A2. A2 is the area of the second rectangle. Let me remove the highlighting. Look like a square, right? The A2 look like a square. What is this length? Tell me, anybody. What is this length? This one. It's very easy to understand. You don't know? This is 1 and A is having x coordinate 2 from the diagram, right? It's very simple, right? It's very simple. A having coordinate 2 comma 0, meaning that A is at 2. A is at 2. What is the distance between 1 and 2? The distance between 1 and 2 is 1. It's very simple, right? If you don't understand, all the dimensions are available in the diagram. So 1, 2 are the corner, this vertices. The distance is 1. Is that okay? Ashlyn, മനസ്സിലായോ ഞാൻ പറഞ്ഞത്? Ashlyn, ശ്രദ്ധിച്ചോ?
Yes, sir.
Devasri, Raj, everyone is clear? Aaron, everyone is okay?
Yes, sir.
Okay. So 1. This side is already given in the diagram. Okay, what about this? This is already given in the diagram. Breadth is 1 given in the diagram. I am discussing textbook question. Okay. Length into breadth will be what is that? 1 into 1. Understood? It will be 1. So if you are given a sheet, a center of mass for a sheet, you need to find the areas of each connected sheets. A1, A2 is required. After that, not completed, we need the center of mass of each sheets. We need center of mass of each sheets. Each rectangle will have their own center of mass. You agree with me? I mean, for the first rectangle, it will have a center of mass somewhere here, right? This is the center of mass of the first area. So center of mass of each areas are required. The center of mass of A1 may be somewhere here, exactly at the center. Can you suggest the coordinate of the center of mass of A1? Anybody? Tell me. You just look at the diagram. What is the center of mass of A1? Maybe here, exactly at the center. How will you find it? No idea? Then I will discuss then. The coordinates is required. You do one thing. Draw a vertical dot line like this. It is at the center, right? Draw a horizontal dot line like this. That point is at the center. For the first rectangle, I am talking about the first rectangle. Let me delete. This length should be half. Understood? That point is the center. So this length should be half of 1. Understood? You agree with me? This length is 1 actually. This point should be the center. Meaning that this distance will be 1 by 2. You agree with me? Please respond. This length is 1 by 2. Is that okay?
Yes, sir.
I hope you have understood. So the center of mass will have x coordinate 1 by 2. I don't want to write all the measurements in the diagram. So clearly the x coordinate of the center of mass will be 1 by 2. This distance is clearly 1 by 2. Now height. The height is the y coordinate. The height is what? This one. This height is the y coordinate of the center of mass. This height. It will be 1. Half of 2, right? Half of 2. Center, understood. So this height should be 1. 1 by 2 comma 1 will be the center of mass of the first area. I hope you have understood. So till this step you are okay? Till this step? All of it clear?
Yes, sir.
Center of mass of the first area denoted by x1, y1. Don't forget about the symbol. The center of mass of the first area x1, y1. The center of mass of the second area x2, y2. Don't forget the symbol. So x1, y1 is the center of mass of the first area. 1 by 2 comma 1. All the details should be written. Till this step you are okay. I hope you have understood. Raj, you can ask me doubt. Raj, are you okay? Is that okay? Now A2. About A2, this point will be the center of mass of A2. Center of mass will be exactly at the center, right? Is that okay? Okay. Then tell me, look at the diagram carefully. What is the x coordinate of center of mass of A2? Anybody? Can you suggest? It is not a big mathematics. Simple mass. Simple mass. The x coordinate of the center of mass of A2. If you don't know, let us do the same thing. Draw dot line vertically. Okay. So the x coordinate of A2. X coordinate of the center of mass A2 will be this distance. Is that correct? I cannot highlight further. This distance will be the x coordinate of the center of mass of A2. This distance is Let me delete something unnecessary numbers from this diagram. This distance is 1. You agree with me? This distance is 1 and this distance is 1 by 2. The square has the side 1. Understood? The square has the side 1. I have already told you. So I hope you have understood. For the time being, let me delete this one. I will repeat. So this distance is the center of mass of A2. So that will be this much distance. This much distance is required. In that distance, this point to this point is 1. This point to this point is 1. And this point to this point should be half. Because the side of the square is 1. We know that. So this should be half. This is exactly at the center of the square. That is why. This is 1 and this is half. So A2 has the x coordinate 1 plus half. A2, the center of mass of A2 has x coordinate 1 plus half. 1 plus half. Let me write it. After that you can ask me doubts. X coordinate of the center of mass of A2 will be 1 plus half. 1 plus half will be 3 by 2. Let me complete it. After that you can ask me doubts. And y coordinate of the center of mass of A2 will be this distance. Y coordinate of the center of mass of A2 will be this height. Clearly this height is 1 by 2. Because the side of the square is 1. This is exactly at the center. So y coordinate will be this vertical distance. It is 1 by 2. So you please write down all these steps. I will delete these numbers from the diagram, and till this step you just write everything till this step. Not completed yet. If you don't understand any step, please ask me. If you have written and no doubt, you can raise your hand. Ashlin, okay, no doubt. Raj, understood. No doubt. Devasri, you are writing. Aaron also, you are writing. Aaron finished. Devasri, do you have any doubt? You understood, Devasri?
Yes.
Okay. Then let me continue. My request is you better memorize the formula. Center of mass has the coordinates capital letter X, capital letter Y. Never forget this symbol. Center of mass of the entire sheet. L-shaped sheet. Denoted by capital letter X, capital letter Y. Never forget this formula. X equal to A1 X1. This is about area. A2 X2. Formula I have already explained that. Okay. A1 X1 plus A2 X2 plus A3. A3 is not there in the diagram. A1 and A2, only A1 and A2. So A3 not required. A1 X1 plus A2 X2 plus A3 X3 by A1 plus A2 plus A3. A1 plus A2. Simply substitute the value. All the numbers are written there. A1. A1 is 2. X1. Yes, it is there. You just look at the. I have written everything. Don't worry. X1 is what? X1 is 1 by 2. Understood? Just compare. Look here. x1 is 1 by 2. So x1 is 1 by 2. You have to write all the details first. Okay. A2. Ah,
A1 and A2 is the length, right?
A1 and A2 are the areas. A1 and A2 are the areas. Okay.
Okay.
A2. A2 is the area of the second sheet. It is 1. I am simply substituting. Okay.
Okay, sir.
x2. What is x2? Is it written? Yes. x2 is 3 by 2. Look here. You just look here. x2 is 3 by 2. Right? Denominator is a1 plus a2. Means total area. Denominator is the total area. a1 plus a2 will be 2 plus 1. Only one question is there, solved example is there in textbook, but you practice all the numericals, then only you will have a confidence. Okay. Shall I discuss the calculation? I don't want to discuss the calculation. You can do the calculation later. Okay, so that I can save time. You will get 5 by 6. I don't want to explain the calculation. You can do later. Okay. So x coordinate of the L-shaped sheet I found. X coordinate of the center of mass of the L-shaped sheet. In the same way, y coordinate of the center of mass of the L-shaped sheet. The similar formula a1 y1 plus a2 y2 plus divided by a1 plus a2. a1 written there. y1. Just look here. y1 is 1. Understood? y1 is 1. a2 is 1. y2 y2 is 1 by 2 by a1 plus a2, that is 2 plus 1. 2 plus 1 by 2 divided by 3, same value you will get 5 by 6. Let me write the remaining steps here. So final answer is center of mass CM is capital X, position is x comma y. The CM is center of mass. The coordinates of the center of mass will be capital X comma capital Y, 5 by 6 comma 5 by 6. 5 by 6 comma 5 by 6 may be somewhere here. No need to plot it. 5 by 6 comma 5 by 6 somewhere here, meaning that I have to keep my finger here at 5 by 6 and comma 5 by 6. The L-shaped metallic sheet can be balanced if I keep my finger exactly at 5 by 6 comma 5 by 6. Understood? So all of you please write down. If you have written and no doubt, raise your hand. If you have written and no doubt, raise your hand. Please remove your old raise hand. This one is homework. Okay. What I have done is I made a small modification in this question. But if you do in the class, it will take time. So let it be homework for you. The similar question is given to you. The dimensions, a small change in the dimension. The same technique you can use. So let it be homework. All of you please send me homework solution today or tomorrow. Okay. Don't delay. Please write the homework question. If you have written, draw the figure, then raise your hand. Devasri, Ashlyn, okay, written. Aaron, okay, everyone has written, okay. Then next is a small theory, no problems, okay, no question, just it will be asked as a theory question. A little bit of mathematics is required regarding vector, but I will make you understand, okay, a little bit of a vector concept is required here. Motion of a center of mass. Motion of a center of mass. All of you please listen. All of you please listen. Suppose there is a big, there is a, what is that? Okay, I have a system of masses. Okay, I have a system of particles. For example, I have a bundle. Understood? I have a big object. I have a big object which contains point masses m1, m2, m3, m4, okay, etc. I have a system of particles. System of particles means I have a system which containing masses, point masses m1, m2, m3, etc. Understood? If m1, m2, okay, this entire system will have a center of mass. You agree with me, right? The entire system, m1, m2, m3, m4, plenty of point masses. A system containing a plenty of point masses. As long as m1, m2, m3 are fixed, the center of mass remains fixed. Some center of mass will be, it is a point, imaginary point at which the entire mass is assumed to be concentrated. Meaning that using my finger I can balance the system. Okay, understood? As long as m1, m2, m3, etc. are stationary, the center of mass fixed, does not move, does not change. But if the system is moving here and there, understood? Clear? For example, m1 is moving inside the system. Inside the system, say m1 is moving with some velocity. m1 is moving with some velocity, say v1. It's a vector quantity. Understood? m2 is moving with some velocity v2. m3 is moving with some velocity, say v3, etc. If the components are moving, then definitely the position of the center of mass may change. Understood? If m1, m2, m3 are fixed, there is no change in the position of the center of mass. If m1, m2, m3 are moving, definitely the center of mass is also moving. Position will be keep on changing. You agree with me? Is that correct? Please respond. Please respond.
Yes, sir.
Okay. Actually, there is no numericals based on this concept, so don't worry about that. A theory question will be asked. Okay. So if you refer textbook, if you read the NCERT textbook, you cannot understand this theory. You will not be able to understand the theory. It's very difficult to understand. So I am trying to make you easier. Okay. So okay, the center of mass will have a position. We have another formula for finding the position vector of the center of mass, but in numerical question we never use this formula. Okay, we will never use this formula. The center of mass in vector format we can write like this, meaning that I will tell you in the right side I will write. Okay, suppose in the right side I will write, but in numericals we will never use it, don't worry. So I have a system, m1 is here, m2 is here, m3 is here, etc., etc. You know that there will be x-axis and y-axis, right? Let me explain a small theory. There will be x-axis and y-axis. This is the origin, understood? So in vector format we can write the position of the center of mass. Okay. But in numericals we will use only coordinates. Understood? That we studied in the last class. We vector format we don't use in numerical, but let me express in vector format. Let me join m1 and origin. Okay. Let me draw dot lines. Let me join the position of m1 with the origin. Will I get a vector? Yes. This is said to be the position vector. Position vector means the position of m1 is joined with the origin. Understood? The position of m1 is joined with the origin. That vector is said to be position vector of m1. That's all. Okay. So this is a vector quantity. Let us denote it by say some letter, say r1. Let me give some letter r1. Position, that's all. Okay, m2. Vector I have already explained. So M2, let me join O and the position of M2. Can I join position of M2 with the origin? Yes. We get a vector. It is denoted by R2. R2 is the vector, position vector of M2. Position vector means the position of the point mass is connected with the origin. We get a vector. Similarly, origin and position of M3 is connected. We get another vector R3 like that. So R1, R2, R3, etc. are the position vectors of M1, M2, M3, etc. Then remember, definitely this entire system will have a center of mass. Okay, maybe somewhere here. The entire system will have a center of mass. Understood. At that point we can balance it. If I join the origin with the position of center of mass, that vector is said to be position vector of the center of mass denoted by capital letter R. So capital letter R is the position vector of the center of mass. Origin and the position of center of mass joined. We get the vector capital letter R, which is said to be position vector of the center of mass. There is a formula. It will be asked as a theory question. So just write the formula. I will write in the right side. The position vector of the center of mass is given by M1 R1. In vector format, we are able to find the position vector of center of mass. M1 R1 plus M2 R2 plus M3 R3 plus each masses to be multiplied with their respective position vectors. Each masses to be multiplied with their respective position vectors divided by M1 plus M2 plus M3 plus etc. Put it in a box. So all of you please write down this somewhere in the right side. Okay, this formula is required, then only I can discuss this theory part. Theory, it will not be asked as a numerical problem. So all of you please write down the right hand side. The right side, all of you please write. If you have written and understood the concept, you can raise your hand. If you don't understand anything, you please ask me. If you have written, understood, raise your hand. Ashlyn understood. Devasri okay. Aaron okay. Okay. So coming back to motion of the center of mass. So as long as M1, M2, M3 are fixed, my finger, the position of my finger remains fixed. If the bodies keep on moving here and there, I have to adjust the position of my finger. Understood? Otherwise, I will not be able to balance the system. If the body is moving here and there, shall I adjust my finger? Definitely. The center of mass will be moving if each component masses are moving. That's my point. So what is the formula of the position vector of the center of mass? That diagram, look at this diagram. Okay. The position vector is each masses to be multiplied with their own position vectors. Or position. Okay. M1 R1 plus M2 R2 plus M3 R3 plus etc. Divide by M1 plus M2 plus M3. Understood. What is this M1 plus M2 plus M3 etc.? M1 plus M2 plus M3 etc. will be the total mass of the system. Understood? M1 plus M2 plus M3 plus M4 etc. will be the total mass of the system mass. Let me denote M1 plus M2 plus M3 by a capital letter M. I will write here. m1 plus m2 plus m3 plus etc. is the total mass of the system. Let me denote by capital letter. A little bit of mathematics is required. Okay, let me do the cross multiplication. mr. It's very simple. You just do the cross multiplication. mr equal to m1 r1 plus m2 r2 plus m3 r3 etc. And the next step is mathematics. Actually, you not studied yet. In 11th standard, there is a chapter differentiation. In 11th standard maths, you will learn one chapter differentiation. So the next step is actually differentiation. But if I explain about differentiation, you cannot follow. So to simplify, to give a rough idea, let me explain in another way. So you know that if the body is moving, what happens that the R1, R2, R3 are changing, right? If M1 is moving, the R1 will be changing. You agree with me? If M1, M2, M3 are moving, the positions are also changing. R1, R2, R3 will be changing. So let me divide, not exact step, to make you understand. Let me explain in another way. Let me divide each side by time. Each side is divided by time. Understood? Every time they are changing. Understood? So each side is divided by time. Okay? Time. So r by t, you know that the velocity is the distance divided by time. Understood? R is nothing but it is the position, displacement. R is R1, R2, R3 is nothing but it is the position or displacement. So r by t will be the change in displacement in 1 second. Let me divide each side by t. Precisely speaking, we are differentiating with respect to t, but if I say differentiating with respect to t, you cannot understand. So roughly speaking, let me say dividing each side by t, time. So r1 by t will be the position change in 1 second. A quantity divided by time will be the change in quantity in 1 second. So r1 by t is the velocity of m1. What is y velocity? Velocity is the change in position in 1 second. Change in position in 1 second. So r1 by t means in 1 second how much change happens in r1. How much change happens in position. So each side divided by t. So r1 by t is nothing but the velocity. Displacement by time is velocity. Understood? Displacement by time is velocity. So r1 by t is nothing but it is the velocity of the first body. Each sides are divided by time. Precisely differentiating with respect to time. But let me avoid the term differentiation. m2 into r2 by t. r2 by t means the displacement of the second body in 1 second. That is nothing but velocity of the second body. m3 v3. r3 by t will be velocity of the third body, etc. etc. Capital letter m into r by t. Yes. The center of mass has the position or displacement capital letter r. So if the bodies are moving in different directions, is the center of mass moving? Yes, the center of mass will be moving in some directions. The finger, understood. The finger should be adjusted appropriately. So if the bodies are moving, the center of mass will also be moving. So the center of mass will be moving with a certain velocity. The velocity at which the center of mass is moving is denoted by capital letter V. The center of mass will be moving only if the component masses are moving. So r by t means capital letter r by t means in 1 second. In 1 second time, how much position change happens for center of mass. It is the velocity at which the center of mass is moving. Velocity at which the center of mass is moving. Actually, in NCERT textbook, I have not seen any question, but it is required for competitive exams. For NEET, JEE exams, this formula is very, very important. So ultimately what I have got is m into v is equal to m1 v1 plus m2 v2 plus m3 v3 etc. So by conclusion is capital letter M into V. The capital letter M is the mass of the entire system. Capital letter M is the mass of the entire system. Capital letter V is the speed at which the center of mass is moving. So mv is simply said to be the total momentum of the system. Let me write in sentence. Total momentum. Mass into velocity is actually momentum, right? I will repeat, don't worry. Let me write the equation. Total momentum of the system of particles. Of the system of particles. Let me conclude. System of particles. Why it is total momentum? Capital letter M is the total mass of this entire system. Velocity is we assume that the entire mass is concentrated at here, cm. The entire mass is concentrated at here, we assume. And it is moving with the velocity v. So mass, total mass into the net velocity is said to be the total momentum of the system. The total momentum of the system of particle equal to the sum of each momentum of the each individual masses. m1 v1 is the momentum of the first mass. m2 v2 is the momentum of the second mass. m3 v3 is the momentum of the third mass. So conclusion is this. It will be asked as the theory question only. Okay, I have not seen any numericals in NCERT. The total momentum of the system is equal to the sum of the vector sum of the each momentums. Each masses will have their own momentum. So each momentum, the momentum of each masses to be added together, we get the total momentum of the entire system. So this is our conclusion. So it will be asked as a theory question. Show that derive the formula for finding the total momentum of the system of particle. May be asked as a theory question. These are the steps. So all of you please write down. If you have written and no doubt, you can raise your hand. Devasri understood. Aaron okay. Raj okay. ആഷ്ലിൻ എന്തെങ്കിലും മനസ്സിലായിട്ടില്ലേ ചോദിക്കാം കേട്ടോ. ആഷ്ലിൻ കേട്ടോ?
Okay, sir.
So this is okay, clear. The next, is it necessary that each component masses moving with a fixed velocity? No. Each component masses may have accelerations. It is not necessary that each component masses moving with a fixed velocity. They may have acceleration. The moving body may have, not necessary, the moving body may have acceleration. So m1, let us imagine like that. Suppose m1 is moving having some acceleration a1. Acceleration is change in velocity by time, right? m2 is moving with some acceleration a2. Let me write here. m3 is moving with the velocity v3, but it can also have some acceleration a3. Acceleration is the change in velocity in 1 second. Acceleration is change in velocity in 1 second. So if each component masses having acceleration, definitely the center of mass will also be moving with some acceleration. Okay, let me denote it by a sorry, capital letter A, but not, it is not area. We use capital letters. Let me draw like this, so you will not have any doubt. Capital letter A vector. Capital letter A vector is the acceleration of the center of mass. If the component masses are accelerating, definitely the center of mass will also be accelerating, having acceleration capital letter A. So that formula also to be derived. So very simple, very simple. 1 minute. Let me make a blank page. Let me make a blank page. So my next objective is what is the at what acceleration the body is moving. Okay, the net acceleration. Okay, so we have a formula mv equal to m1 v1 plus m2 v2 plus m3 v3. So okay, remember this form. Okay, no problem. Remember this formula, and I want acceleration also. So let me write this equation again. Let me write this equation again. Is that okay? Let me write the same equation. What is that? M into V equal to m1 v1 plus m2 v2 plus m3 v3 etc etc. Just theory concepts. You know the, let me divide by time each side. Okay, in the earlier case I have divided by time. Again let me divide by t. Precisely speaking, differentiating with respect to time. Differentiating with respect to time. Since you are not familiar with the differentiation, let me explain in another way. Let me explain in another way. Each sides divided by time. Each sides divided by time. What happens here? Right side, please tell me. F1 into. What is V1 by t? V1 by t means in 1 second how much change in velocity. Understood? Divided by time means in 1 second what is the change in velocity. V1 by time is nothing but it is acceleration. V1 by t, think like that. In 1 second how much change in velocity. So V1 by t is the acceleration of the first body. V2 by t is the acceleration of the second body. Acceleration of the third body, etc. V by t. V by t is what? V by t is the acceleration of the center of mass. V is the velocity of the center of mass. V by t will be the acceleration of the center of mass. So from this formula, you are able to find out capital letter A. You can take this capital letter M to the other side. Okay, no problem. Just remember this formula. It is very easy to memorize. That is why. So acceleration of the system of particle, we can use this formula. And for velocity of the system of particles, capital letter V, we can use this formula. If they ask, if there is any numerical questions, you first of all you write the formula. Capital letter M can be taken to the other side. Then you can substitute. So MA equal to M1 A1 plus M2 A2 plus M3 A3. What is the meaning of this equation? Okay, we can interpret this equation in another way. In the earlier case, we interpreted this equation in terms of momentum. We interpreted this equation in the form of momentum, because mass into velocity is actually momentum. That is why. How can I interpret it? M1 A1 is the force experienced by M1. Mass into acceleration, is it momentum? No. Mass into acceleration is the force. Mass into acceleration is what? It is a force. So M1 A1 is the force experienced by M1. Understood? Someone is applying certain force on the system. Understood? For example, I have a big object system. If somebody applies some external force, the force experienced by M1 may not be this one, and a small fraction of external force is experienced by M1. Understood? Somebody apply a force on this entire system. It's a very large system. A small fraction of this the applied force is experienced by m1. Understood? m1a1 is the force experienced by m1. m1a1 is, it is the force experienced by the m1. m2a2. m2a2 is the force experienced by m2. A small fraction of external force is appeared on m2. That's why m2a2 is the force experienced by m2. m3a3 is the force experienced by m3, etc., etc. m into a, that is very, very important. M into a. I will repeat, but you listen. Let me complete that formula. What is that? M into a. Capital letter M is the total mass of this entire system. Capital letter M is the total mass of the entire system, which is assumed to be concentrated at Cm. Capital letter M is the total mass of the system, which is assumed to be concentrated at Cm. And capital letter A is the acceleration of the Cm. So M into capital letter A is nothing but it is the external force. Because we assume that all the masses are concentrated at this point. All the masses are concentrated at this point. At that point is moving with the capital letter A acceleration. So what I am saying is M into capital letter A is the force experienced by the total mass. M into capital letter A is the force experienced by the total mass. It is nothing but the external force. It's a very important formula. I am applying some external force, this very large system, understood? Very large system, but each masses experience a fraction of external forces, F1, F2, F3, etc. So what I am saying is M into A is the total force, external force we are applying on the system. This is important. It will be asked as a theory question. Show that in a system of particles, derive the formula for the total external force acting on the body. Okay. So conclusion is the the net external force. Okay. By conclusion, let me write the conclusion sentence. Net external force acting on the system of particles. On the system of particles equal to the vector sum of the forces experienced by each point masses of the system. So all of you please write down. It will be asked as a theory question. You have to write all these steps. Okay, it's very simple. Derivation does not take much time. So all of you please write down. If you are okay, written, raise your hand. If you are okay and written, raise your hand. Aaron understood. Don't leave the class. Aaron, Devasri, Ashlin, all of you clear?
Yes, sir.
Okay. Next is law of conservation of momentum. I think it is better to discuss in the next class. It's very easy to understand. The law of conservation of angular momentum is there. After that, the rotation of the system of particle is the a big chapter. The average level numerical problems I will discuss, and I am planning